So this is the beginning of the next section. Operations with radicals means, well, operations are just addition, subtraction, multiplication, division. So beginning, it's just we're going to add, subtract radicals. That's it. So pause and read this, I guess, the little sentence at the top here. But basically what you have to do is exactly what you do when you combine like terms. So if you combine like terms, let's say if 5x squared and 3x squared, you subtract them, you get 2x squared. All right? These work exactly the same way. Right? You just got to make sure that the index matches for both things and the radicand, what's inside the radical, match for both radicals. All right? So that's the case for all three of these right here. All three of these. All right? It's a 3, a 3, and a 3 for the index. They're cube roots. And the radicand is the same for all three things. All right? So it really is, as far as what you do, exactly like as if you were combining like terms. So it's 1 of these minus 4 of these plus 8 of these. So it's 1 minus 4 is -3 plus 8 is 5. So it's going to be a 5 times the cube root of yz. That's the answer. Now, the second example here, the like terms are actually, or excuse me, the like radicals are only the first one and the third one. Okay? These are all square roots. The first three are square root. This is a square root right here. This is a square root right here. This is a square root right here. The first three. However, the radicands are different. This radicand is different. It's odd man out. It's 5x. You cannot combine unlike terms. You cannot combine unlike radicals. This guy's odd man out. This is cube root. So it's got the 3x, 3x, 3x. Now the fact that it's a cube root makes it not a like radical. So what do you do with those? Nothing. So these combined, these are like. So you get, well, 4 minus 2. So it's just 2 radical 3x. And then really, there's nothing to do with the rest of it. They just kind of come along. So it's radical 5x plus 3 radical 3x. There's really nothing else to do with those. They just, there you go. Now, look down here. None of these look like terms, or like radicals. The terms, just the root radical. Okay? And how you do that is by simplifying the radicals like you have done in the past. You've done in algebra 2. You've done a little bit in here some. Alright, and so there's a couple different ways to show your work. So, I mean, if I'm going to show the work a little bit differently than what you've seen, then sorry, maybe I'll do both here. Alright, but you can break this down into a perfect square. And we want a perfect square because these are square roots. So we look for perfect squares. 4 and 2. You break this down into 25 and 2. So I'm going to show more work than perhaps you would show if you remember how to do these. This is plus, now this guy right here is going to be root of 4 square root of 2. Might not need to do that. Okay. And then this guy is, if you look, you just had 1 square root of 2 plus 2 square root of 4 is 2. That's fine. I can erase all of that. Equals radical 2 plus 2 radical 2 plus, this is 5 radical 2. So it's 1 plus 2 plus 5, so it's 8 radical 2. not supposed to use calculators in this class, but it might hammer it home that if you actually throw this big mess in your calculator, get some decimal, I don't know, I want to say 12-ish almost, 11, 12. Yeah. And then if you plug this in, your calculator, you can see they are equivalent. Okay. For this one, last but not least, that's a quick video for you guys. We look for perfect cubes. Nothing to do here. Can't do anything to simplify it. We look for perfect cubes because that's a cube root. And so the perfect cube, the only perfect cube that goes into 32 is 8. 8, 4. All right? So when we rewrite this, this can become cube root of the 8, cube root of the 4, and the x, minus 2 cube root of 4x. So it becomes cube root of 8 is 2. Cube root of 4x minus 2 cube root of 4x. Wait a second, those cancel. So they are 0, whole thing 0. Just by design I made it work. But there you go. Hopefully that's helpful for tomorrow's lesson.